Yeah,
What is this place?
if we're in AP Calculus, we're gonna have to do some math. No! What's that?
It looks like a sign. It's a math question.
Oh no, we're doomed. Alright, so our two equations are r equals 5 and r equals 5 sine of 5 theta. So, to find where these intersect, we want to set them equal to each other. Alright, so the first point of intersection is going to be at theta equals pi over 10. So now what we want to do is plug this into the equation for r equals 5 sine of 5 theta. We want to find the area of this from 0 to pi over 10. But because the equation r equals 5 sine of 5 theta has 5 pedals, at theta equals pi over 10, that's only half of a pedal. So we're going to need to multiply the solution to this all by 10. Now, the formula for finding the area under a polar curve is the integral of 1/2 r squared d theta. So now what we want to do is take our calculator out and plug this into the calculator because this is not realistic to solve by hand. So for this we get 19.635. So the equation r equals 5 is just a circle. So we can use the formula pi equals r squared. So now, because the equation r equals 5 sine of 5 theta is inside of r equals 5 theta, we want to add those together to get our solution.
No, Isaac, you goofed it up. You see, he wants the area inside the circle, but outside the polar curve. So this is wrong. You would actually have to subtract the area under the polar curve from the area of the circle. So this is, in reality, 25 pi minus 19.635.
Oh, shucks. It would be terrible if something bad happened now.
So, as it turns out, the answer the ghost was looking for is in reality 58.905, approximately. Hey Isaac, good job, but where were you hiding that calculator?
Don't ask stupid questions.
Isaac, what's that?
I must be cursed.
Isaac!
Dude, I think Isaac might have been cursed.
Yeah, dude, I don't know where he is.
Do you think we're being like haunted by the ghost of calculus?
I hope not. Where's Danny? What's that?
Okay, so in this question, they're asking for the volume when these three equations, y equals 2, x equals 0, and y equals 8 minus x, are rotated around the x-axis. So those three equations enclose this area right here, and we're going to use the disk method to find that volume rotated this way around the x-axis. So for this method, the volume is pi times the integral from a to b of height squared. So for our question, the height is this rectangle minus this one, representing the area from y equals 8 minus x to y equals 2. And they intersect at the point 6, 2, so our integral is going to be from 0 to 6. So the volume is pi times the integral of 0 to 6, and it's going to be the height, 8 minus x, minus 2, all squared. And that simplifies 2 pi times the integral from 0 to 6 of x squared minus 12x plus 36. Now to solve this integral, we take the antiderivative, so it's going to be pi times 1/3 x cubed minus 6x squared plus 36x, evaluated on the range from 0 to 6, and that equals pi times 72, or 72 pi for the final volume.
Where am I? Where's Steven? It's another math problem. Oh, it's about Maclaurin and Taylor series. Oh man. So, it would seem that what I need to do to find the interval of convergence is to do the ratio test. So I'll set the limit with n approaching infinity as this sum of n plus 1 multiplied by the reciprocal the normal function. As to divide n plus 1 by the regular series. So now I can cancel some terms. And as n approaches infinity, this limit is equal to x plus 3 over 8. And I know that in order for this series to converge, this has to be less than or the absolute value of this has to be less than 1. So, set this up so that x plus 3 over 8 is greater than negative 1, but less than positive 1. And now we'll solve for x. But now I don't know whether my endpoints are actually a part of the interval. So I have to test whether they converge or diverge. So we'll plug in these values for x to test that. So this series, if I cancel some terms, is the same as this. Which equals, now, according to the nth term test, since the limit as this approaches infinity does not equal 0, 11 is not a part of my interval. So now I test 5, and I do the same thing. Now this series is equal to 8n. And for the same reason, according to the nth term test, this is not a part of our interval. So thus, our interval equals negative 11 is less than or equal to x is less than or equal to 5. Oh no. Oh no. That's not right. In reality, since these aren't a part of our interval, this is equal to negative 11 is less than x is less than 5. I got the math problem wrong. Oh no.
So in this question, it's asking for the arc length of two parametric equations. So we have y equals 2t and x equals t squared minus 4. So for parametric arc length, the equation is length equals the integral from a to b of the square root of v sub x squared plus v sub y squared. So to solve this, we're going to have to take the derivative of the y and x equations. So dy over dt equals 2, and dx over dt equals 2t. So we have the length of the path equals from a to b, or from 0 to 4, which is the range of t values we're using, and the square root of 2t all squared plus 2 squared. That simplifies to the integral from 0 to 4 of the square root of 4t squared plus 4, which comes out to 18.587 feet. So we are 18.587 feet away from the door. Only 18 feet away? It's not right.
There's the door.